All right, so you should have gotten the link to the pre-class videos. I don't know, did Kai give you anything last week, or was the stuff that I posted in the channel, the pre-class videos and the information about the getting your C environment set up, was that all new today when I posted that?
That was new.
Okay. Well, if you didn't get a chance to watch all the videos, we're going to go over a lot of that today. I would encourage you to watch those if you have time later and if you have any questions. And apparently the way they've got this set up, it's changed a little bit since I've last done this GP because it's been a while, but I guess you're supposed to actually get your environment set up. That said, it's pretty simple to do. It's a lot more simple to me than like getting Python or something like that set up. So we'll talk a little bit about it today, and we'll go from there. And like I said, I will be around this afternoon if you have any questions until Kai gets back in about 15 hours or 3 o'clock Lambda time. So just real quick, I'm going to talk through kind of the rationale behind doing this module, why it's important to learn C. And it's important to learn C because it's still used extensively in fields of computer science like operating systems, Unix and Linux, in embedded systems. It's used, just off the top of my head, an important use of it is writing drivers, whether it's for, something like a printer or whatnot. That's all still written in C. Many high-level programming languages are written in C. Examples are PHP, Ruby, Python is written in C. And manual memory management, which we mostly will brush on it a little bit today, and just kind of the theory of it, but mostly Kai will be going over that tomorrow. But manual memory management gives you a better understanding of how things like register, stack, and the heap and all of that work. C also produces a more efficient program than many higher level programming languages. In other words, it literally is able to run faster than a program that has a whole lot of stuff going on up under the hood, because with C, you have to deal with the memory. You have to deal with referencing and dereferencing and the pointers to that memory. You've got to deal with typing. Can y'all remind me what your background is? Did y'all both come from iOS, or y'all?
I came from iOS.
I'm from a full stack.
Full stack, okay. So coming from iOS, you're pretty used to typing. We'll talk about that today. But to me, typing is not being a strongly typed language is not. The real difficult thing that most people have with C is the memory allocation, which you'll cover tomorrow, and the referencing, which we'll cover pretty extensively today. Don't get discouraged with it. It's not something that most people pick up immediately. It's something where you just have those aha moments along the way. We'll go through as much as we can today in the GP, and then during your repo that you work through today, I think a lot of it today, tomorrow, and as we work through the week will become a lot more obvious to you. So it's certainly nothing I picked up the first time around when I heard it. It's certainly not something that most people pick up. You may be the rare case of it just clicks for you, or you may have experience with C in the past, but in general, it's one of those things that takes a little bit of time to get used to. So the takeaways from this module, we're going to talk about the basic requirements of a C program, talk about the variables in C and them being strongly typed. In other words, them having to have what type of variable they are. It's not like JavaScript where we just create a variable and we can assign anything into it and it all gets handled up under the hood, the typing. We actually have to deal with that here. We'll talk about the syntax of loops and conditionals, types of expressions, and then pointer types. So the address of and dereferencing, the specific syntax to get that. Using pointers with strings and arrays. We'll see how strings are represented in C and see how strings are dealt with under the hood. And passing pointers to variables into functions, which we'll talk about why we use those, why we want to do that, and how we do that, and kind of what the results are when we do something like that. So we went through the pre-class. I talked about the pre-class videos. there's two different ways, and I'm just going to, you've used Python Tutor before. So within Python Tutor, you've got this as well, and we'll mess with this a little bit later. But the basic way of running a C program, if you're just here in VS Code, I'm going to go down here and change this to C, save this to my desktop, and we'll just call it intro C. C. We'll save it. So the include statement in C that you just saw me use right here is basically the same as import in another language. So this include stdio, standard input and output, is something that you're probably going to see and need in just about any C program that we deal with here. Your print, your ability to do basic operations, most of that, if you Google it, you can get an exhaustive list of it. I don't have anything handy right here, but you're going to pretty much see this anywhere. So this is just importing this module, and the syntax is the include. When you use, one thing to point out, when you use the Python tutor, you do not have to include the imports, but you must include the imports. And we'll see some examples of some additional imports that we have to include later on. But you just have that, and then your basic syntax, we'll say int. Now the int is the type of the return. So we'll talk about that more later, but depending on what we're going to be returning, but in this case, we're just going to be returning an integer. So we'll say int main, and the entry point for any application written in C is the main function. So we'll have main, and then we'll have void, because we're not passing anything into it. And because we imported that standard input output, we can use a printf statement, which is included in there, and we'll just say hello world, like we always do. And we will also include this in. Same thing that we used in Python, that is just a new line. A question that commonly comes up are about the semicolons at the end. You must include them in C. There's no tolerance in C, like other programs don't require, or other programming languages don't require it. Other programming languages are more tolerant with you, but at the end of any expression, you have to have that semicolon. If not, you'll end up throwing errors when you go to compile. And here we're just going to say return 0. You have to have some sort of a return in the C. In this case, you could also use an exit code. We'll talk about a little bit about that later, the exit function. But return 0, in this case, I know a lot of time with the Boolean, 0 is false, 1 is true. Here, a 0 is actually basically returning success, whereas return 1, return 2, return 3 are different error codes or issues that are related to a problem that was discovered. So where that comes in use is later on if you have a conditional, and your conditional dictates, based on what happened within the program, your conditional dictates the return. A return 0, just remember for now, is that the program was a success. So we'll have that return statement, and if we just save it here, and then I can go down. Oh. No, here. Yeah, so you can't actually, there's not that deal like there is in Python. But I'm already in there. So I just CD'd into the desktop where I've got this intro to C saved. So the syntax is GCC, this wall and Wextra that I'm putting in, you don't have to have in there. These are specific. I'll try to find a link to it later. There is a link to it, and I will be able to find it. These flags are just dictating what types of error messages we want to generate. You don't have to have this in here. You can look up exactly what these allow you to access, but just know, I think the takeaway to know is include these for now, because these will allow you to get error messages that can be helpful. And then this O flag is actually what we're going to output it to. We can name it anything. I'm going to name it intro to C. So this, when we compile this right here, which is what this command is doing, the O flag and whatever you have after it is going to be the name of what we're going to compile it to. And then we'll just say intro C.C, and this is actually the file that we're going to compile. So this is a must because this is the name of the file that we've saved right here. This we can name anything, but it's pretty common convention just to name it the same once it's been compiled. So if we do that, and now if we look here, you can see that right here we have our compiled file, and I can just say ./intro C, and we get our hello world. So this is the basic way that, and if you go over here like we've done before, like I said, you don't have to have this in here. And you visualize the execution. Why is it taking so long? And you get your hello world after this line, and then you just get that return a 0, which does nothing. So know that you can use this. One thing to point out is that I believe, like Python, there are certain modules in C that are not handled by here. So if you've got some modules, like I said, that we'll talk about more later, and they're not working in here, it very well could be. Everything that we do today should function just fine in here. And it might not be the case. I don't remember off the top of my head, but if you keep getting errors, you may want to switch over to here, like I said, where you actually have to use the include for all these. And that pretty much, I will drop, this is included in that link that I gave you right here, but I'll drop it in the channel as well. We'll just say this is compiled file and target to, so this is just simply like we were just talking about, whatever the name is here and what we're wanting to output it to. Like I was saying up here, if we wanted to go back here and just call this garbage, and you'll see now we have, well, I misspelled it, Gargabe. And if you just said, you get your same hello world. Okay, any questions? I'm not going to draw. I used to be pretty heavy on dropping surveys, but since there's only 2 of us, if you didn't ask the question, you know that the other person's asking the question. So if you have any questions, speak up. You can unmute your mic if you want to, since there's only 2 of us, but I'll definitely stop and ask if there's any questions. But at this point, anybody have anything, or we good to move on?
I'm good.
Good?
I'm good.
Okay. So a couple questions. Do we have to have a main, and can there be more than one? Basically, the answer is yes, there has to be a main if you want a program to run, because when you go to run the program looks for the main when you're going to run it. If you don't have main, you can compile it, but there's nothing for it to do. So it's kind of a lot like in Python when we used that standard syntax that we had to use as the entry point for the Python program when we had the main. But in this case, we don't have the double underscores or anything like that. There can only be one main in a program. Into story. There can be individual files that don't have a main, but when the whole project is built out, the main is brought in from another source. So let's say some of these libraries that we're talking about, they might not have a main in them, and we're accessing different things from the standard input output, from whatever module, from whatever library we're bringing in. It doesn't necessarily have a main in it, but because we've got the main here and we're bringing this in and we're bringing this printf in from here, it doesn't need a main here, but every program does have to have this main as an entry point. And so we're just calling the routines out of this standard input output, for example. Another question, can main return void? And what about main with no parameters? And you can have main, in the past, you could have main with no parameters. So let's say, and they do it over here if you notice, well, I think I changed it, but I just reset this. They do it here. They don't have the void. But that's old syntax. Historically, they were equivalent in int main void and int main, just like this were equivalent. Know that this still uses this syntax, but when we're typing here, I think if we go right here and we try to compile this, and know that if you go back and you recompile it, you're just going to overwrite this right here. So we've already compiled this, and we've still got this sitting in the directory, but know that this is just going to overwrite this. But if we try to run this, I think this is going to throw it. Actually didn't. I thought it was going to throw an error. Yeah, it lets you do it. But you should always have the void in there. And the other thing is, it's not always going to be a void if you're passing arguments in, whether you're passing by value or passing by reference, which we'll talk to later, then they're going to be here. So we will see that. But if there's nothing that you're passing in, it's simply going to be void. So also, we talked about the return 0. It doesn't have to return that. That's, like I said, the exit status. But because it's passing it a lot of times, because we've got different modules, when we return this 0, a lot of times that allows us to make decisions on what happens in other parts of the program based on the exit status. So it's a good idea to always have an exit status if you can. Think of it like a way of exiting a program, and you're passing a small piece of information back, an integer in this case, to the program that spawned it. So like I said, 0 by convention means success by convention, not by a hard written rule. And non-zero means failure. And the idea is there's typically only one way for a program to succeed, but there could be many reasons, just like you've got many HTTP error codes that can come up. And that allows us to use other integers, +1, +2, +3, as these error codes. Like I said, we can also use an exit call, an exit status code within that exit call, and we will talk about that more later. But for now, just know that if you're not actually returning a value, which we'll see that as well later, you should be returning the exit status, in this case, the 0, the success of this program.
I have a question.
What's
Uh,
up?
when you're commenting, can you use the hashtag? But I just noticed that like when you included the header file, you used the
So you
number.
just, yeah, that is used in this syntax right here. It's just double. It's just like in JavaScript.
Okay, thanks.
So you're using the double forward slash. So if you wanted to comment something, you could just come up here and say, just like that. And the main always needs to be at the bottom of the program. We did it that way by convention in JavaScript. In C, there is a feature that you must declare a function before you use it. In other words, it must be when we invoke that main, you have to actually invoke it at the bottom. So the main has to appear before that. Does that make sense? I think the way that you were taught in JavaScript, say for instance, or I can't even remember in Swift if you actually, do you actually have to do that in Swift? I can't recall, or can you write things out of order?
I don't remember.
Yeah, just know that you have, if you're gonna invoke something in C, it has to appear above it, physically above it in the program, or you're going to throw a whole bunch of errors. There's a way to declare functions with prototypes and then put the definition of main before the definition of the other function, but we really don't need to worry about that right now. So it needs to be above it in the program. And like I said, you can use prototypes, but CDEVs tend to put main at the bottom of the file that contains it. A CDEV is going to expect it that way. It's not frowned upon or wrong to use the prototype. If you want more information, go Google it or talk to me afterwards. There's no reason for us to really go over it right here. But those are just kind of some points I wanted to go over that related to kind of some of the basics of C. So like I talked about in the introduction, C is strongly typed. So if you come from Swift or if you've got languages in your background that were strongly typed, this is simple. And like I said, the take home from this, you always have to specify a type when you declare a new variable. So, and I'm just going to keep commenting these out. And then at the end, I will drop these in the channel so that you can have a copy of them. But if we were going to do here, our include, that .h stands for header, if you happen to be curious about why that H is there, but that just stands for the header file. We're going to say int because what the type of the return is an int. We're just going to return the status at the end, but remember, in returning that 0, that's an integer, so we have to say int main. We're not passing it anything, so we'll say void. For the curly braces in C, you can put them here like this without a problem. The convention is to place them the way that I'm placing them. I can't even remember what Python tutor
Sorry,
does.
I have a question. I might have missed it. We can leave the parameter blank, right? I mean, are you gonna pass anything from the parameter?
Right here?
Yeah.
No, we're not passing anything in, and that's why I put void. And yes, I mean, I was able to leave it blank and not put the void in there, but you need to, if there's not anything you're passing in, you need to put in the void to avoid problems. It used to be equivalent just to do that, but you can run into problems now. So it's just best to always have void. You're certainly not going to hurt anything by having void, and you'll see how we pass things in later, and then we won't have the void in there. That makes sense? All that void is doing is just saying there's nothing being passed in. So we can say int main void, and like I said, by typical convention, the open brace and the open curly brace and the closing brace are put on a new line. So we can say int x equals 2. So we are declaring a variable named x, type integer, just assigning it the value of 2. It's an integer, I'll put that here, and an integer is 16 bits. How many bits are in a byte? How many bits are in a byte? Somebody. Because a lot of times you'll hear these referred to as bytes, and you need to, it's not, I mean, it's something you can just Google quick, and it's not deathly important, but you do, especially when we get into memory management, you do need to remember how many, depending on what type we're dealing with, how much memory each common type occupies. So 8 bits in a byte, so an integer, just a regular old signed integer in this case, is going to be 2 bytes, 16 bits, however you want to think of that. We can say float, y, we'll give it the value of pi, so 3.14. And that is a single precision floating decimal point. And that is 32 bits, so 4 bytes. A double, we'll call it Z, and we'll just say 2.5, but know that that is a double precision floating. I made a typo up here. I should have put floating point. Remember, so if it's not an integer, if it's got numbers after the decimal, it's going to be a float, and the double float just allows for more degrees of precision in that number. And because of that, it's going to be 64 bits. So it allows for 2 times the amount of precision, but it also takes up 2 times the amount of memory. And the character, keep in mind, this is a single character. We'll talk about strings and how they're a little bit different here in a bit. But in this case, it's a single character. We're just calling it C. We're assigning it B. And this is just a character. And it is 16 bits, like a simple integer, 2 bytes. So the take home of all that, and we'll see using the print a little bit, we'll say X is, and this right here, I'm going to give you a link real quick. So if you didn't have the link, here is the Python tutor specifically for C. There's a link to that. And also, when you see, I'm going to give you a link to this. Don't worry about it right now, but we'll talk about this a little more. This tutorials point, in my mind, has the best online tutorials when it comes to C. So if you just go, you can go to the home and the reference, and you've got all these useful links here. Give you this, and this will give you all of the so for example, like you're about to see me use a D, that's a signed decimal integer. So when we're using the print, we actually have to tell it what type we want it to print in, and we'll go into a little bit more detail of how that gets a little bit complicated. But in this case, X is an integer, so we just need to say X is D/N just means new line. And then, much like in Python, this X right here, we're simply saying this X, we want to print this out as an integer, and we're giving it this integer right here. So we'll see if you could have multiple statements in here. Remember, it just corresponds one to one. And then if you had another one, it would just correspond to the second and correspond to the third. Remember, you have to have your semicolon. You can have printf, y is, and this is a float. And we're putting this new line just to pretty up our output so that when we run this program here in a second, we have it all on separate lines. So that we're going to print the float, the value right here in y. And if y'all see me making any mistakes or you think I might have a mistake or you have any question, we're also going to print a float here for z. So notice whether it is a single or a double precision float, you use that same syntax right here, the f. Like I said, you can go back here. There's your decimal floating point. There's not a separate one for single or double. And this gives you all the different ones if you want to have something to reference later. That's why I dropped that for you. Give that z. And then we will print our character. C is, once again, to have this syntax here. And then after it, we'll just have a return statement, our success. And if we save this, go back and compile it. And this is exactly what happens. I did not put the semicolons here, and you see that it won't even compile. So
in your return.
What's that?
In your return 0 as well. There's no semicolon.
Yeah, that's what I'm saying. It's catching each one of these, the 1, 2, 3, 4 assignments and the return, that I failed to do that. That certainly was not intentional. But to forgive me, it's been a little while since I've done C. So this is why we put that wall Wextra in there, because we run this again. Now it compiles, and then we can just say intro C, X is 2, Y is 3.14000, Z is 2.5000, X is B. If I had gone and let's say I left one of these out, and I did not, it's going to save it, and I don't compile it with these, it's not going to compile. I don't think it will throw the specific error. Oh, it does. Okay. Yeah, so I guess this is one of the errors that's kind of built in, that it will throw that wall, and the Wextra allows it. And like I said, you can Google those and look those up exactly what they do. Off the top of my head, I don't remember. It's a good idea right now to include those. You'll run into some cases where you just choose not to include it, or you choose to turn everything off, but you can worry about that in the future. But that did, without me even intentionally doing it, prove the point that you'll definitely throw the errors if you don't. And so a question comes up, and I'll just kind of let y'all answer and see what you come up with. We don't have a specific Boolean type in C. So what do you think we would represent that as? A string, like a true-false string, or what do you think we would represent? How would we implement Booleans in C?
The video said they're done through numbers, so 0 would be false.
Yep.
And the other numbers are true.
Yep. By convention, 0 corresponds to false, 1 corresponds to true. And how do you think we would implement strings since we're just dealing? I told you when we got the characters, we've just got this individual character here. Well, it's only 1 character. How do you think we would implement strings? Remember that from any of the pre-course work? The strings are represented as an array of characters. We'll talk more in detail about how these are implemented today, but just know if we did something like this, and we're just declaring the type character, the variable, and we're saying it's BC, and we went into here, I do believe that it's actually only it's either gonna only print out the B or it's gonna, yeah. So see that it actually only prints out the B. The heck? It actually, so it will compile it. Do know that these warnings allow you to compile, and I think that's what the wall and the Wextra adds in. It adds in all of these warnings. So if you didn't have this, and you didn't have the wall and the Wextra, you wouldn't get these warnings. So we had that character here, the type character, but we had more than 1 character, and you see that doesn't work.
What GCC and the wall and the Wextra mean again?
No, I'm just, watch, if you go right here. If you do this, oh, it still throws the warning without it. I'm gonna have to go back and look at that wall Wextra, exactly what it does in terms of the of helping with the errors. But anyhow, just know that we actually have to make that we'll have a pointer. We'll talk about that in a minute. It's going to be if we want to have a string, if more than 1 character, we have to actually have a pointer to an array of characters, and that's how we deal with strings. But we'll deal with that here in a little bit. And we got a correct output. So take this out. So, like I said, every variable has a type and every expression has a type. Some numeric types are automatically converted. There's something called promotion. So if you add a float to an int, it doesn't matter what order you do it in. If you add a float to an int, if you add an int to a float, actually with the addition operator, the result is a float. If you assign a float into an int, the result is an int. So for example, here we have int x equals 2, but if we said int x equals 2.14 and we saved this and we compiled it, we get the warning and we can just ignore that warning and run it. And right here you see we just have a 2. It just chops that off. So we're going to say int a equals 2, float b equals 3.14. This is an expression, and we talked about expressions. We'll just say print f and a is, remember, it's an int, so we're going to have that D here, new line, and then the value that's there in A. And once again, I am forgetting because I'm used to dealing with Python, but there. And then we can say, we'll talk about all these in a second. We'll say character C, its type character is Z. And then we'll say D equals A plus 10, E equals B plus 10, F equals C plus 10, G equals A plus B. We'll say A equals B. And this really isn't a program that we're going to run or need to print anything out. I'm just wanting to make examples here, so I'm going to put some comments next to it. You know that the return type here of this print is an integer. The return type of this print is an integer because what this is going to print, we just take this out of here, of course, is the 2. So remember, A is an integer. We're adding 10 to it. So what's the return type going to be here? An int plus an int logically is what? An integer. Now B is a float. So a float plus an integer, remember. So float plus int equals a float. Remember, this is not valid syntax here. We're just talking about how this, we would actually have to deal with that in front of it here like we're dealing with these, but these are just little notes I'm putting in, so this will not compile. Here's kind of a weird one, but F equals C plus 10. Remember, C, we said equal to Z. Character plus an integer is an integer. What it does, it's based on the ASCII codes. So it's going to go back and it's going to say right here, what is the ASCII code of C? And if you literally went and looked this up, let's just keep appearing on the top. If you looked up what C, where is it? Should be right. You're literally going to be getting the 99. So this would be equivalent right here of saying 99 plus 10 because it's taking that ASCII value. And so just remember that if you take a character and add an integer to it or an integer plus a character, that becomes an integer, but it's going to be using, it's going to convert the characters over to the ASCII code. Why? That's just because what C does under the hood. Remember, G now equals A plus B. We have an int plus a float.
Do we always have to base it from the ASCII code? I mean,
What do you mean?
Because how do you check it again?
Well, I just looked up the table of the ASCII codes. I cannot think of a reason why you would add an int to a character in C. Certainly there's some reason. We could probably go Google it, but we got a lot to cover. I want to give you all a break here in a second.
Okay.
But just know that with an int plus a character is an int, and it converts the character to its ASCII code and adds it like that. So you're adding an int to an int and getting an int. Like I said, where that actually comes into play, I'm not sure. And in this case, what we're doing is we're assigning a float to an int. So remember, A is a variable of type int, and we're assigning it the value of B, which is a float. And what all that's going to do is you're basically going to be putting 3 in there because it's going to ignore that 0.14. And that's really all I needed to cover there. Like JavaScript, there's a lot of rules, there's a lot of things that go on. But just know that these are the basics. And with that, I'm going to give you all a 5-minute. Let's just come back at 15 after the hour. So it is about 9 after the hour right now. I'm going to pause the share, and we will start talking about pointers when you come back. Were there any questions? Any more questions before we took a quick break?
Do you need to have like semicolons after that? The D equals A plus 10.
This will not run.
Oh, okay.
I just did this and then just went back so I could type these comments in here. This will not compile. This would throw a ton of errors because remember, for every variable, we have to declare a type. So we could come in front of here and we could say int D equals A plus 10. We could say float and all that. But the point of this just was to show what happens within the operation when we start doing these things like adding an int to an int, a float to an int to a float, a character to an int, assigning a float to an int. So this was there's nothing to that. So no, there doesn't need to be anything there. But if you wanted to do print statements at the end with E, F, G, A, you would need to go and type these here correctly and then go into the print statement and have your correct reference here. A D in this case, an F in this case, a D in this case, an F in this case. This is just an assignment, so you wouldn't be able to really print anything here unless you were just going to print A again, in which case this would be an int. Any more questions? So take until about 16 minutes after 5-minute break, and we will start up on pointer types. All right. Can everybody hear me okay? Everybody should be back now. Share my screen again. So we're going to get into the basics of pointers today. There's a lot to cover. This might run over past 3. I'm going to go through all the material. If you've got to go somewhere after 3, or if you don't want to sit in on it, it will be on video. I would encourage anyone, if it does go over, that can stay to stay. Hopefully I can get this all done in the next 43 minutes, but I don't want to rush through it. I want to be able to field any questions that come up. And I want to make sure and cover it all, because this is probably, I would say pointers, referencing, dereferencing is probably the bane of most people's lives in C. Not always, like I said, if you come from a background where you're accustomed to doing that, it's not so bad. But if it's your first go round with something like this, it normally takes a little bit of time to get your head wrapped around it. So we're going to go over a lot of examples today. But the takeaway from this, how do I put this? A memory is like a big array of numbers. And for any given index, in this case, an address, you can read or store values at that index or that address. I'm kind of going to use those two words interchangeably, and I'm going to try to point out, and I'll even drop it in the channel, some of the interchangeable terms that we run across with C that you'll hear people here at Lambda use, other students using, instructors using, people in the industry using, things on Stack Overflow being used, that you kind of need to know what's equivalent to what, so you understand what's being talked about. For all intents and purposes, all variables in your program are stored in memory in that big array. So we've got our memory, we've got a big array of numbers, we've got indexes, addresses in that memory, and all of our variables are stored in that memory. These terms mean the same thing, and I'm going to type them out. And index, I can type into the memory array, memory location, memory address, and pointer, which is the term I'm generally going to be using today. These all refer to the same thing. So really not much more to it than I just want to make that fact clear. We will refer to it as a pointer today, and we'll talk more about what a pointer is. A pointer, a memory address, is just integer numbers. They're just like an array index, but in this case, they're going to be integer numbers, and we're actually going to print some of those out. It's not the same as a zero-based in let's say, a Python array or a JavaScript array. We'll see some zero-based index referencing. We're going to have to bring in a library for that, but just know the actual pointer that we're talking about, this deal here, is a longer integer that the computer itself actually is assigning. You can manually assign it, and we'll see that as well, but just keep that point in mind. You can get a memory address, also known as the pointer to, of any variable with the operator, the ampersand. So the ampersand allows us to access the pointer. So what I'm saying is, let's say here we have int x equals 2. That ampersand actually allows us to access not the 2, but the integer, the memory, where in the physical memory that is located. And vice versa, the dereference operator, the star, allows us to access the value at a pointer. And we will see a lot of examples of these. I just wanted to type this out.
I'm not sure if it's me, but I actually don't see anything. Is it?
Oh, I'm typing up. It's in the it's in the channel right here. Yeah, I'm not putting it in the notes. I'm just dropping this in the channel because it just doesn't. I guess I could have put it in the notes. I'm just dropping this in the channel, and we're going to go over this a lot. Just remember over here, the ampersand allows us to access the pointer. To dereference that pointer, if we have the integer, the spot in memory, the reference to that spot in memory, we can use the star to access the value. And just know that if you assign from one pointer type to another, both expressions on the left and the right of the equal must have identical type. The value at each of the location must be of the same type. The CTutor that we were talking about in the pythontutor.com is a great tool for demoing pointers, but for class, for when you're working. I'm going to keep doing them in here. I'll do one of them over there that's kind of short, but I'm going to keep doing them in here just because I think it is a little more conducive to what you're actually going to be doing in your work, to have to work here in the text editor than instead of using the CTutor. So we'll say int main, and once again we'll say void, and we'll have our open brackets, and we will begin. So we're going to say int x. When we do this, all we've done is we have declared, we have an uninitialized variable. We have int x. There is actually a value in x. You could say right here, print f and you can put and we can do a new line and then x. I think this is all squared away to run. Save it, compile it. What is this? So it's throwing warnings here because there's a garbage value in here. When I say garbage, don't mistake that with like garbage collection, but there's just a garbage value in here. Mind you, when these warnings are generated, it's still compiled, so we can still run intro C, and you get this stupid garbage value for x, because all we did is declared we said x is of type int, but we didn't give it a value. It's an unsigned int, and we got this negative 4818966864. So we could say x equals 12. Now x has a value. Right here, what we have done, a pointer is an integer. A pointer is an integer, remember. So p, the variable p, is type int. It's uninitialized, so it has a garbage value. It has a number in it, but it can be anything. We could go here then. Remember, we can use that ampersand, so we'll say p equals, we'll use ampersand x. Remember, this is allowing us to access x has value 12. This allows us to get, this is referencing x, but it's asking, this is getting the place in memory, the pointer. We specifically declared that type here. Something I'll point out, you could actually also say this int p. Problem with this is that you could declare more than one value here. You could initialize more than one variable. You could say p q, and you would think that we're talking about both of these being a pointer, but actually it's only functioning on here. So that said, it's more semantic to say, what this says here is we're have these uninitialized variables that we're declaring. So this is a pointer, it's an int. This is simply right here going to be an integer. It is not a pointer. Have a little bit more of that later on, but just know that whether the ampersand or the star could be here or here, one and the same. By convention, we put it here for clarity. So now we've got a pointer, and we give that pointer the memory address of x. So if we went here and said printf, and we will put a D, new line, x. What's that going to print? Somebody tell me. Well, it's not going to print anything with the mistake I got in there, but if I had it like this, what is that going to print? Somebody.
Is it going to just print 12?
Yeah, that's all it is. You're just printing 12 because just
12 with the space. I mean, like with the return.
Well, not a return, a new line, remember.
New line.
Yeah. Yeah, I'm going to use these new lines all the time. So if I ask any of these questions, ignore the new line part. The new line, if we don't put that, we're just going to end up with a jumble down here in the output for anything that we're outputting. So yeah, that's just going to print a 12 and return down to a new line, if you would. Now, if we did right here and we said print f, this is a type P. This is another type here, remember, because of this print statement, we have to say what type of a value we're going to print, and this is a pointer specifically, and you need to tell it that specifically. And we'll add in the new line, and we will give it P and tell it to print P. That is going to print the address that P is storing. And then if we did one more print statement, I want somebody to tell me and this is something, it would be great to go into Python or into the Python tutor, the C portion later, and just start messing with these and see what happens and work through your homework, and you'll get a lot more understanding of it. Remember, X refers to the value. P refers to the memory address we've done here of X. So if we go here and do this, what's this going to print? Remember, we talked about earlier over here in the channel what that ampersand and that star do. What's this going to print? Somebody.
It's just going to print the actual number, right?
Which number? There's two numbers here. We've got the value and we've got the memory address. What is this going to print? Remember, P is
the star P will do the value.
Yep. So we've got the address, but we add that star to it. So it just is going to say what's the value at that address, and we go back to the 12. And this is where I mean, it's all logical and makes sense, but it just becomes a big, when you start really working with more complex programs, it gets a little complicated and it becomes a jumble. And that's why, we go over this in detail, and I'm saying it's probably not all going to click, but this is just exactly what it is, dealing with pointers, dealing with being able to access the pointer, accessing the value at a pointer, using the different operators, using the different syntax. And if we were to run this, you would see, I don't have any mistakes in here, which I don't think I do. You get 12, like we said. Here's the memory address. Then you get 12, just like we thought. So I'm going to talk a little bit about strings now. And actually, I'm just going to keep doing it in here for a second. We could say character. Now remember, we're assigning a pointer here. Could also be like this, but by convention, we like to do it like this. We're going to say this is equal to, remember we had a problem earlier where it only gave us one character. It threw those warnings. It only gave us one character. But here, we're giving it a pointer to that character. If we say print f, and we're going to say a p here because we're using a pointer. And then we'll say, give it the C. It's going to print the address. But here, what's going to happen here? Remember, C is a pointer. What's that going to print right there? So assigned to.
The goodbye.
What's that? The goodbye?
Yeah.
Let's see.
Just be G.
Yeah. Where the heck did I miss? Yeah, it's a problem I have. And it's really been exasperated because I haven't been in C in probably two and a half months. So there you got the value stored at the C pointer is G, just the G. But remember that we're storing consecutive blocks. The memory is a contiguous block of memory. So that means if this is what's stored there, if we go to the next spot in memory, what is going to be in the next spot in memory? We're seeing what's in this spot of memory, C, but what if we went to the next spot of memory? Would we see that O?
Yes.
Just did like that. Oh, I know what happened. Why is it not letting me do this?
Oh,
I'm
okay.
missing a there.
Oh, sorry. So on line 63, it prints out the first character of the string, right? I just
Line
know
63 prints out the address. Line 64, when we just had
the plus.
C, if we just have C here,
Oh, sorry. Yeah, 64. It prints out the first character of the string.
yeah.
Okay.
But what I was going to show, so if we run this right here, you get the G. And what I was trying to change that to earlier, you just say C plus 1. And left it out again. And that's what I was trying to get at right here, is that it now points to the O because we've incremented it up one. We'll talk a little bit about, like I keep saying, we'll talk about that more later. So what in your mind, remember we've got loops, we got while loops, we got for loops. What does that allow us to do in C? Remember, we're storing this in a contiguous block of memory and it's iterable. We see, what's that allow us to do with the string? Remember that string is just an array of characters, but if we can iterate over it, then we can go ahead and print out a string, right? We just wouldn't put new lines in there. Let me do an example of that. I'm just going to make this the C again, and this should be correct. So all I'm saying is we can go in here and we could say, we're going to have to do a for loop. So we'll cover the for loop syntax, much like JavaScript. Have a placeholder. We will initiate int I to 0. And we will say I is less than 7. So we're going to start at 0. 0, 1, 2, 3, 4, 5, 6. So we've got 7 characters. 1, 2, 3, 4, 5, 6, 7. That's why I'm saying 7 here. There's another way to do this with a while loop that's a little bit different. And then we can just say I plus plus. And the for loop, the typical, you can just do it like this, where you've got your braces on the same line as they begin. And then we'll just say print F, remember this is a loop, address, and we'll use P. Just put a pipe there, value. And this is where we're using a character and a new line. We'll put a new line in there. And now, so this was an example I talked about earlier where you've got 2 different variables in here, much like we did in Python. So we'll just have the corresponding, like I did earlier, C plus I. It's going to increment it up by 1. And we will dereference. And the reason that didn't work earlier and it gave us a stupid answer is because I didn't have these parentheses here. And you actually need to have, you need to carry this out first before you access the value. And if we do that, we should, I guess for housekeeping here, we should have a return 0 like we did earlier. We can go into here and compile it. What is this doing? C+1. I need to say C+I. Kind of stupid of me. I was wondering why it was printing out all these zeros or O's. So if we run this again, and now we have goodbye. So you see how we can iterate over this array using that arithmetic, be able to deal with our strings here. Anybody have any questions to this point? There's a couple more examples I want to go over. Anybody have any questions to this point?
Wait, can you go to the last line?
What's which line? 67?
Yeah.
Okay.
Can you repeat that line 67 again? Because the P with the axis of the pointer, does it?
Okay.
Yeah, probably again.
So we got a for loop going here, and we're manually going to assign I equal to 0 and and we're going to run this for loop until I is less than 7. We want to iterate 7 times so we can cover these 7 characters. There's ways of doing this. We'll talk about another way of doing this, but for right now, just know that that's why we're doing this. We're just looping through this number of times because we've got 7 characters. So we got 0, 1, 2, 3, 4, 5, 6. And I, each time, we're just incrementing it. So the print, we're just saying the address. Remember the P, we access the address, or excuse me. Here, I'm going up to that. C was the pointer to this string. So it initially points here at this character. At that string is an array of characters, a continuous block of memory. G is in a place in memory. The next place in memory is O. The next place in memory is O. The next place is B. So we're going to iterate over that. So we're saying, remember, it's because it's a pointer. We're needing to say we're wanting the address. So we need to have the P here, and the value is simply going to be a character. We'll do a new line. So then remember, this will correspond to this. This will correspond to this. It's just using more than one variable in a line, like I said, like we did in Python. Is that all clear? And then I'll cover what we're doing here. But is that clear what we're doing so far?
Yeah.
Okay. So then here, we're just going to say C plus I. So the first time around, it's just C. Remember, C is the actual memory pointer, and that's why we're getting this right here. And then we're going to iterate up 1. Remember, it increments, so next it's 1. So it's going to be C plus 1, and then C plus 2, and then C plus 3. We're going to that next block in memory, plus 1, plus 2, plus 3. Now remember, that memory could be a different size depending on whether we got ints in there that are 2 bytes or floats that are 4 bytes or double floats that are 8 bytes. And that's why we've got to have, when we have something like this, it's all got to be the same type, because under the hood in itself, C knows how many bits, how many bytes that each block of memory is accepting, and it allows us to use this math just by saying plus 1, plus 2, plus 3. Is that clear? So here we're just actually accessing the address, and here we're taking that address and accessing the value of it with the star, just like we did above. Make sense?
Yes.
Okay. Yeah, definitely. If something doesn't make sense, or if there's questions, ask, and be honest if an explanation doesn't. This, like I said, this is probably the most difficult aspect of of C. I have another example here. And we will say include I'm going to say int a equals 99. We're going to make a pointer here equals, remember this is just going to allow us to get the address of A. We'll do print. We can do just say A times 4. That's just going to print the value of the int A times 4. So in this case, all we're asking it to do is print 99 times 4. So it's going to print what, 396. And then this is a pointer. Remember, we have to use this syntax if we're going to access a pointer. We'll just say P. We'll give, remember this is how we do a string. We'll say name equals Austin. We're going to print the pointer. And we're going to actually have to use remember this syntax allows us to get that address, printing the pointer to the character in name. And if we want to print the string, and if we run this, first piece, we got the 396 like we expected, the A times 4. This gives us the value of that pointer that we were talking about earlier, the pointer to A. And then here, we're asking for the value of the pointer. And then here, we're just actually asking for the value. Different than here, we said C. When we use that S, it appeared over here, string of characters. It allows us, without that iteration that I showed you earlier, it allowed us to print the entire value stored here in name. Any questions? We'll talk about kind of another tricky instance.
Sorry, really quick. What is the S again on line 86?
That S on line 86 is the same. Remember that link I gave you?
Oh, string.
It's just allowing you, because we're using that printf, it's giving that format. Remember, we use the D, the signed decimal integer. We use the C, where that is a character. Use the F, the float, the S. Just allows you a little bit of work going on under the hood. P, we used a pointer address. This allows us to print out the entire string without having to go iterate over it like we did. I showed you how we could iterate over it, and we will indeed need to, both in the work later, practically, there's times where we're going to have to iterate over something, but depending on what we're trying to do. Another void here. Okay, so we're going to say int a, and here we're going to talk about pointers to a pointer. And we're using that ampersand to get that place in memory. And I'm just using it like this here, but remember, you also could just say, and that's the same, but we'll see here that it functions in the same manner. And then if we had a print, we'll print that pointer, put a new line in there. And the P, and that's just going to print the pointer to the int A. And we'll do something here you might have seen before. We're going to say int Q equals, remember, P is the pointer to A. P is of type pointer. P points to A. Now we're using that ampersand with the P, so we're getting, pointers also are stored in memory. We've seen these printed out, like these addresses. So this is saying Q is the pointer to P, which is the pointer to A, which holds the value 99.
Oh, so it reference to that double reference, the star sign reference 6 and 9. What do you call it?
A double pointer?
Double pointer, it reference to 96 and 95.
Okay, Q is referencing the pointer to line 96, the variable in line 96, P, because of this ampersand. P in itself, here, we've given it this type because of this. Remember, we could have put the star here, but we put the star here. That's saying this is a pointer because of this ampersand to A. You could make a pointer to a pointer to a point. I saw Tom Tarpey. He made like 6 or 7 different pointers where it was like a pointer to 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 prove a point. But just know that for now, and you'll go over this more in your work, and this is something that I don't want to spend a ton of time on because we're already running out of time. And like I said, oh, no, I'm not meaning to cut off, but yeah, know that a double star is a double pointer. It's a pointer to a pointer. So then down here, if we said print f and we gave it the type pointer, the new line, Q, this will give us the pointer to the pointer. Say D, because here we're going to say we've got P, but we will add a star in front of it. That just accesses the value at P. So in short, what we've done here, at our standard input output that we've included, remember the include is the same as import, have our main function. It's going to have an integer return. We could say return 0, status at the end. Void, because we don't have any arguments to give it. Open our curly braces. Variable of type integer is the value 99. We're having a pointer because of that. This could be in either spot. We're just going to use this ampersand with A to get that memory address, the pointer. Remember, those are one and the same. Printing that pointer using this P here because of the fact that it's a pointer. Just putting the P in to correspond to that. And we'll have this double reference. The Q now becomes a pointer to P, which is a pointer, a double pointer, a pointer to a pointer. Then we'll print Q and we'll see that's a pointer. And then we'll just print P with the star. So that takes that memory address that we've done with P and accesses the value. So this here prints 99. This prints the memory address of the pointer to P. And if we go run this, we get this memory address that we expected. We get the memory address here. So this points right here to A. This points to this. This piece of memory points to this piece of memory, which points to this value. And then when we simply take this value that's pointing to 99, we add the star, and we get 99. Any questions there? So like I said, this is something you're going to have to mess around with a little bit. It's not real intuitive. It's a lot to take in the first day. I've still got a few more things to run through. If anybody's got to take off right now, it is lunch hour. This is probably going to run over about another 20 minutes. I would encourage you, if you can stay, to stay. If not, the video will be posted with all of this. But there's a couple more things I wanted to go over with strings, and then passing values by reference as opposed to passing a value by a value. So if you need to take off, go ahead and take off. I'm going to give everybody a real short break, about 2 minutes. And I will resume here. Like I said, I've got about 3 more demonstrations to do, and we will call it an afternoon. But does anyone have any questions up to this point about anything that we've covered? I'm going to go ahead now, and I'm going to drop, let's see. Gave you that link. There is no official documentation, like there's the official Python docs. There's no official documentation to see. Like I said, that tutorials point that I dropped you earlier here, there's a lot of good reference to it that's written in pretty plain English. This is a good reference, but it's a huge book that's hundreds of pages. But if you want to find out the exact, I have the link. I'm going to have to find it somewhere. Beej actually wrote a very in-depth introduction to C that he published long ago that's available for free on the internet. I'll get the address to that if anybody, the link to that if anybody wants it. But this is another pretty good reference here. I gave you this link here to Tutorials Point and pointed out that overall that this has a lot of good information and tutorials on C. This is your repo that you've got for the week. And you've already got this link that I gave you before the GP started. That talks about getting your C environment set up. So basically, after we're done here, you need to get your C compiler up and running. Just go through here if you haven't already. If you're running Mac, if you've got, you shouldn't have a whole lot of trouble getting this set up, but we're not going to cover any of that right now. If you have problems, feel free to DM me. If you have any problems during the day, like I was saying earlier, just to make sure everybody heard, Kai will be back for the rest of the week, and Kai will be back for the day at 3 o'clock Lambda time this afternoon. Until then, if you have anything, you just need to add him as a contributor. But if you have any questions, you can post in the channel, post where you usually do for help, or you can DM me. I'll be your point of reference until Kai returns this afternoon. So here's your repo, and you've got this link as well already up high. And then tomorrow we'll be talking about dynamic memory allocation. But today what I wanted to continue walking through is so I'm just going to take just a second here. I wanted to get a few things in order. Okay, so here we want to talk about how we can use pointers to access specific characters in our string. And for this, let me grab something real quick. I'm actually going to give you, let's see, where is it? Somebody asked earlier, and this is the same table that I went to. I just had to go back and look for it. It's going to be turned off the share. This is that ASCII table that I was speaking of. So just realize that in a string, like I said, strings are an array of characters. Each character is the next block in memory. It's 16 bits, 2 bytes further ahead in memory, and under the hood, C allows us to iterate over that or use arithmetic, pointer arithmetic, to be able to access specific spots in that string. We went here and said int main void Something else I want to put I want to note, when you do this, it's not here, but under the hood, there's also a null terminator at the end of a string. So this is a way that if we were iterating through the string, we could keep looking at each value and checking. And once we've reached this value, we know we've reached the end of the string. Because we won't know how long that string is that we've put in there unless we've just happened to have just programmed it. But we won't always know how long that value is. But we know when we hit that null terminator, and we'll see an example of this just here in a second. When we hit that null terminator, we've reached the end of the string. Does that make sense? Does anyone have any questions about that? So right here, we're storing in the string HELLO exclamation mark, a new line, and then there's actually that null terminator at the end. Now, if you ask for the length of this string, it will not include that null terminator. Do remember that. The length will give you the actual length of what we put in here, 1, 2, 3, 4, 5, 6, 7, but it does not give us that null terminator. But that is there, that is present there. This actually gives us this is just going to give us the address to right here, the H. Remember what we did earlier when we had the same syntax, we were saving this in that array that just points to this is the beginning pointer. That's all we're asking for here. And so if we wanted the value that it pointed to, and some of this, like I said, we've gone over in previous ones. Now here, remember this print, we're going to say type D. Remember that's an integer. And the S is that pointer in memory, so it's the piece in memory that's pointing to this H, but we're asking it the ASCII value, if I can spell right here, of the character that S points to. So we're going to use this D here. If we change this to a C, our output would be H. But because of the D, this is actually going to give us the ASCII value of the H.
It will give like the memory of every letter.
What's that?
Every letter, it will give like the decimal point.
Well, not every letter, because remember, we're not iterating here. This right here, we're just accessing this first letter. We're going to iterate here in a second, but this is just accessing it. This is because we're asking for it. Remember earlier we were talking about if you added an int and a character, you ended up with an int because it went to the ASCII values. That's just another quirk, or I don't know if it's necessarily a quirk. It's just another aspect of C that if you actually ask for in this print statement and you say the integer, it's going to give you the ASCII value. It's not changing it. The H is still there, but it's giving you the ASCII value by doing that. That makes sense? What doesn't make sense is I never can remember. But if we go back down here, make sure I save it here. And then we got that pointer. We got that ASCII value to the H. And if we go up here, where's our link to our ASCII table? Right here. If we go to the little h, you see we have 104 right here. That's the HTML, but we have 104. And that's why we got the 104 returning here. Remember, we talked about this earlier, but if we went in here and we said print F and we said value after where S points, this is going to be a character. So we're going to use the C in a new line and S plus 1. Remember, S points to here, so S plus 1 then points to E. Did this earlier, just going back over it again. And if we did it we wanted the integer, the ASCII, we could use the D in a new line. And put the same thing here, S plus 1. And just a few examples, I talked about this earlier, but we can use a while loop. While this is getting the actual value of S, while it's not equal to, like I talked about, the null terminator, the print, the character, the null or the new line, value of S, and we'll iterate S up. Another way to do that without the while loop, you could use a for loop with array bracket notation. Because we're using array bracket notation, something I want to note here is we need to include, what's the name of that library? String.h here. So something we can do here, and the reason we need to include this is because we're going to say going to have a variable named length, and we're going to call this stringlen, strlen of S. This requires this library. Once again, if you were in here in the C tutor, you wouldn't need this. It would handle it for you. But in our case here, we need to include it here in this text editor. So we're getting the length of the string. And remember, that length is going to give you that null terminator as well. I is less than the length because we got it starting at 0 index and we increment it. Remember, print statement. And that will be a character, a new line, and we will access using the bracket notation S to the I. And you need the string line 106, the import, the include to do that. So we're just saying S at the 0, S at the 1, S at the 2, S at the 3, S at the 4. And you can see, let's go to the end here. Add that for housekeeping. Just kind of looking over everything here. This should all run nicely. So we'll save it. So right here, remember H, E was the second letter. The value after where S points, the character is E. This is the ASCII code like we did for the H. And then you have H, E, L, L, O, an exclamation point, and then you get your new line and the space that just comes in here. So if you took out the new line here and did this all back over, we don't end up with that new line in here. So just know that when you're getting that string length, it's going to include that new line, but what it doesn't include is that invisible null terminator that we know that's in here as well. So when you allocate, we'll talk about when we allocate memory. When you allocate memory for a string, you've got to give it a specific amount of memory. It's not dynamic, which there's really nothing that's dynamic. All up under the hood, it's having to use memory allocation no matter what language you're using. But know that that's not included in the length, but there is a spot in memory for that null terminator. But when you access the length, since we're zero based, we'll go from 0 to less than the length, much like we would in JavaScript. We're printing each of those, and we get that hello with the exclamation mark. The last thing I wanted to talk about in here was when you use a for loop. Say int I equals 0, I is less than length, I plus plus, and we'll say print f the character, the null terminator, and we will say s plus I. And we get the same thing here. The reason we get two spaces in here is there's a new line after all of them. Remember, this is invoking a new line because there's another character after it, and then we have that new line at the end here. So each of these is bouncing to a new line, and then when this bounces to the new line, it gives us one more new line, just in case anybody I think somebody in the past has asked about that, but we get that same output. Exact same output, 3 different ways of doing it. Anybody have any questions?
Do you always have to say null at the end, even though you've stated that in your parameters that it's less than the length?
Null is in. Now, are you talking about that null terminator?
Yeah.
The \0 that I spoke of?
Yeah.
The null terminator happens up under the hood. You don't have to give it the null terminator. When you create right here, when you create this line under the hood, you got a null terminator. This is a piece of memory, a piece of memory. All these are a piece of memory. This new line is just so we have a pretty output down here. But after this, remember, in this string, in that array, we've got an H, an E, an L, an L, an O, an exclamation, and a new line, and a null terminator. And this takes up a piece of memory, but it's an invisible. It's not counted in the length. It's not printed out when you print it. You can print this with that S like we did above with Austin, where it prints the whole string. So you don't have to deal with this. Just know that you can use it like we did here to use in this while loop. And we just keep saying each time we're iterating through, we're checking. And when it gets to this null terminator, we know we're at the end of the string. Here, we used bracket notation like we've used in Python and JavaScript, like we use in a lot of languages. We're just going from I to I less than length. And here we're just using I less than length. And we're just iterating up from R. So here we're just actually addressing the specific piece in memory based on the index. Here we're accessing it by adding. We're using that arithmetic each time it's adding to the S. 0, then 1, then 2. Remember the S just being the memory pointer that points to the beginning of the string, H. Make sense? We talked about being able to interchange this being here, star being after the char, or whatever type it is, or the star being here. But remember that we do that because if we have multiple initiations here, the memory pointer actually only points, if we do it here, it's the same thing, but say we didn't have anything over here and we just said char S. And T, what you're doing here is you're initializing with garbage values because nothing's been assigned to it, a pointer here and a character here. Pointer to this character string here and a character here. But if we do it like this, we could say that's the same thing, or we can make both of them pointers. Variables are stored in memory. Where are pointers stored? Remember that pointers are also stored in memory. They're also stored in memory. We talked about the null terminator. I guess the basics, and you'll see more of it as you work through it, but if you're going to assign a pointer, you should, what it's pointing to should already exist, if that makes sense. You wouldn't just want to initialize a pointer that was blank in general. Does that make sense? If you have something that's already existing, an integer, a character, a float, whatever it may be, then it could, if you needed it, and we'll talk about referencing, we'll talk about the different uses of pointers here in a few seconds, and that'll be the end of this module today. But it should already exist if you're going to create a pointer to it. Otherwise, you're just pointing to a garbage value, which doesn't make sense. There's no, if it doesn't already exist, there's no point in making a pointer to it. So like if you went here and just wherever, if you had this and you had int p, that's not actually declaring an int. It's not creating a variable with p as an integer in it. All this is doing is creating a pointer named p to a garbage value. So if you already have an existing thing that you want to point to, if it exists and you want to point to it, then by all means create a pointer. If it doesn't exist, there's no reason to create a pointer to it. If there's no reason to create a pointer to it, then why would you create a pointer to it? Reasons for creating a pointer. One is being able to pass things by reference and not by value, which we'll see here coming up, which allows us to actually change. And if you pass something by reference into a function, we'll see you actually change the value of it in memory. Using pointers allows you to do pointer arithmetic like we talked about earlier, like we did here, where we're accessing different ways, specific indexes, specific addresses. We've got these characters. Trying trying to think. There's a few other uses, but the common use really is being able to use the pointer arithmetic like we've highlighted, and being able to pass as a reference and not a value. So we'll talk about that now. Let me make sure all this code is still working. I've been changing things up. What did I do? And there we've got the code correct. I don't even know what I did. It doesn't really matter. Okay, any questions up to this point, or I'm going to go over the last little bit of what we wanted to cover today and get y'all out of here. Any questions? Okay, so we're going to talk a little bit about passing values by reference. When you see that void, the return type of void, this indicates that no value is referenced by the function. So when I say that, I'm talking about, like, let's say right here, if we're not going to return anything, we could say void right here as well. Remember, it has to have some sort of a return type. We're using the int normally because we have this return 0. But if we're going to return nothing, this would all run the same way. If I did this, and then went to compile it again, it's going to throw a warning that it will still run. But if we went here, we took the void out of here and just said main void. Once again, it's letting us do it. But this is not proper syntax. So if you put void, that means that no value is returned by the function. We're not returning an exit status. We're not returning, using the exit that we talked about earlier. So in this case, if we're not going to return anything, a lot of times we're passing arguments by reference to modify them directly within the function as opposed to modifying a copy of the value. So if we've got this, we've got a variable, I'm going to go ahead and type this out. So for example, if we have, we'll say include we're going to call this void. We're going to call it make 99. We're going to give it, we're going to pass in a pointer. Passing in a pointer. Remember, this star could be here as well. This is interchangeable, but in this case, I'll just leave it like that. And we're manually setting that P, the value of the pointer, 299. Remember, this is all just for an example. Then we're going to say main void we're going to declare a variable x and make it 12. We're going to print this now and say x is, and we're going to use an integer, a new line, and simply x, and that's just going to print 12 right there. And then we're going to use our make 99 function to set x to 99 by passing in the address of x. And then we'll use the ampersand operator to get the address. Because we've got to pass the make 99 is looking for a pointer here. It's not looking for a value, it's looking for a pointer. So what we do then, which we'll go down to here, say make 99, x has the value 12. So we can use ampersand x, and that passes in the pointer to x, pointer in memory, which is what that's expecting here. And then it's setting that pointer to be 99. So we're just reassigning that pointer. So here it's going to have a realistic pointer like we've seen above this mess right here. But just to be real clear, we're going to replace it manually with 99, which means nothing. But to show how this works, then we can say print f x is d and we're going to get a 99. And remember, because there's void here, there will be no return. If you put in a return here, best case, it's syntactically incorrect. Worst case, I think this will actually throw an error. But I've been wrong all day about these because, like I said, unfortunately, I'm not incredibly sharp on all the ins and outs of C. No, actually, let me compile it. I'm surprised they let me do that. But we don't want that here. Syntactically, that's incorrect. And if we do the same, we compile it again, we get x is 12 as we expected here because we've simply assigned x to be in type integer, a variable of type integer, given it the value 12. We print it out here using the syntax we have exhaustively used today. But then we're going to pass that reference to x. The reference, what's pointing to this, 299, and we make that value 99. Remember, we're just using P here because that's what we've used. We could use anything here. We could use A, B, C. We could use Sam. We could use whatever. It's a variable name. But that's allowing us to change this, and it's changing it in that physical spot in memory because of the way we've passed it. Does that make sense? Does anyone have any questions? If you have any questions, ask. We're almost to the end. But just keep in mind, if you take anything away from this before we get to the independent project for today, take away the fact that if you pass by reference like we do here, we're actually able to physically change that piece of memory, that value that memory reference is pointing to in the program. If we pass by value, not by the memory spot, but just the value itself, this just being like a value, So if we just passed this x, we just called this p, we set this to 99, then we had x here, we printed the value of x.
It's just like overriding it, right?
Well, here it does nothing because we passed this by value. We didn't pass it by reference. But by passing it by reference as we originally did, see we have 12 and 12 here where we change it to 99. By passing it by reference, we're actually able to go in and change that value of x in memory. See? That makes sense? So did that answer your question you were asking?
Yeah. Which exercises are we going to do for the project repo?
So today for the project, get your compiler up and running. If you already don't have your environment working, refer back to that link. And then you will do, I'll put it here, you will do FizzBuzz. You're going to do as many as you can. But the MVP for today is FizzBuzz, strings, and pointers. The last piece I was going to go over, another example of passing by reference, and this is one that I forgot to include earlier actually, but another example of passing by reference is passing an array of characters, a string. Remember, a string here in C is simply an array of characters. That's going to be our last example we do. And then we're going to get out of here. So take this out. I'm going to have one last thing here. We're going to include our standard input output. We're going to include our string because of some things we're going to use, and we will have a void because we're not going to return anything. We'll call it add title and update age. And when we're naming, remember we've had different conventions in different languages. When we're naming things, this is the typical way with underscores and lowercase that we name things in C. The arguments we're going to give it are this pointer to a character, which is a string here. And we're also going to give it an integer for age. And we're going to say string cat. Remember, we're going to have to pass things here in a minute to it. The string cat is just saying take this, concatenate it together. So take whatever we passed in here as name and concatenate it to the great, the string the great. And we can say age. Remember, this is giving a piece, this is a pointer here, or you could change and say this, but we don't like it like this, but this is a pointer. This is accessing the value of that pointer. So that's something that's easy to get confused on because it looks the same, but this is referencing a pointer. This is the pointer now here, and we're actually accessing the value of that pointer with that. So we'll say plus equals 5. We can do that same thing. Same syntax we've used in more higher level languages with that plus equal, and that's all we're going to do here. And then down in our main, I hope this will kind of explain what I'm trying to show here. Let's say void for the main. And we'll return 0 at the end here, so don't forget. We're going to allocate some memory here, and we'll talk more about this later. Just know that this is allocating 50 spaces of memory, so you're allocating enough room for 50 characters. And this also, actually 49, you're allocating enough room for 49 characters and the null terminator. And we're going to say int age is 35. This is just copying. So remember, this is concatenating the two. We'll see that more in the output. This strcpy string copy. We're copying to name, this variable name that we've given 50 memory spots. No reason particularly, just an arbitrary number I gave it. But we're giving it 50 spaces in memory. We're copying to it King George. So we're actually using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces in memory, including that null terminator. And I'm going to give it a space.
I don't see like what is the operator on your line 159? I don't see it clearly. Is that the pointer and then the other one is plus sign, right?
Remember we took in age. So this is referencing age, but we don't want to add 5 to it because that's a pointer, but we're accessing the value of the pointer, which we named age, and we're declaring it here. Here we're going to pass. We're going to invoke this function down at the bottom here in the main, and we're going to pass it name and age. So we're passing it 35, but we're passing it as a reference, not by a value, so that we're able to change it like we discussed up here. And then we're simply saying to that value of this pointer that we're passing it, add 5 to it. So what we're doing is taking 35, passing in a pointer to 35 here, accessing the value 35, and adding 5 to it, and that changes it in the main memory, in that block of memory. We're not passing a copy. Copy, we could do a print statement at the end and do some operations on it, but it's going to leave it, it's not going to mutate the value in memory. Does that answer your question?
Yeah, I was just double checking because I don't see the symbol clearly. I thought it's like both pointers. But it's okay, yeah.
Think of it like this. We're passing it in just like we do in other languages. We're passing it in this argument age. That age is a pointer, okay? Now, to be able to get the value of age, which down here we're setting to 35, and we're going to pass it up to here, we're going to invoke this function up under here in a minute. We're passing it the pointer to age, and then to access that value, we have to use the star here. So when we pass this in later, we're passing it a pointer to 35. We're accessing that 35 using the star. We're adding 5 to it, and we'll see that when we get a return that we print out. Does that make sense? And then here, just actually allocating the space and memory for the string. We're giving the age the value of 35. And we're saying this string copy, and we're just saying here the variable name, give it the value King George with a space. Go look this up more later if you want to, the specifics of what this is doing or what the specifics of what this is doing. And then we'll say printf. We're going to use an S here, not a C. And remember, this allows us to actually access the whole string up under the hood, name. And that's going to say King George with a space. Then we're going to invoke add Why didn't it let me? Why didn't it let me have the predictive? Guess it doesn't do it for C. Add title and update age, and we will pass it name. And we will pass it age. And remember, we need to pass these both as pointers. So this syntax actually creates a pointer. Know that. You don't have this in there. I'm going to change this back to the way we're supposed to do it. I was just changing that earlier so I could try to explain a little bit better what I was doing. This creates a pointer right here. You don't have to have that star in there. So we can just say name because we're passing it a pointer. We're not passing it King George. We're passing it the pointer to King George. And then we will use the ampersand for the age to pass it the pointer to the age so we can match the type we're expecting in the argument and so we can manipulate it up here. And then we'll print the string in a new line. The name, and we'll print the integer age. And so we're assigning name and age here, copying King George over to this name, printing the name so we see what we have. Then we're invoking this with the pointer to name and the pointer to age. Remember, we created a pointer here without that star because of this memory allocation that we'll talk a lot more about tomorrow. And then we use this ampersand to get the pointer to age. We're going to print the name and the age again. Remember, we've just given it the value King George here. We've given it the memory, then given it King George, we've given age 35. But we're going to end up with King George the Great and 40. Because remember, this concatenates name. We're passing it that name with the Great. So it's going to change the name King George to King George the Great, and it's going to change the age 35. It's going to plus equals 5 and change it to 40. Because we're passing it by reference. Remember, I went up here and I showed you if we passed these by value, I went and changed all that. It didn't change at the end. Oh, what do I have messed up here? So we have King George. We printed out this value here when we assigned it. And like I said, we ended up with King George the Great and age being 40, even though we assigned it here to the memory and the King George and the age of 35, because we passed it by reference to here. We concatenated this to name and therefore changed name under the hood. That's what that's doing. It's changing the value of name. We see that here. And then we change the value of age. And if we went back through, it would take a little bit longer, but if we went back through and made the changes I did up here where we were passing it by value and not reference, it wouldn't be the case. Any questions? that's come to the end. I'm going to drop this all in the channel. Remember, you can't just grab this and run this because it's got a ton of these mains in here, but you'll have a copy of all the code that we did, a working copy of all the code. Remember, this piece didn't run. That was just some examples I was using.
Do you also mind sharing the GitHub repository for the assignment for today?
Right here.
Couldn't.
In the channel, it should be right here in the Sprint 3 channel. It's right here.
The FizzBuzz strings and pointer.
There's the FizzBuzz. There's the string. There's the pointer.
Ah, got it.
And then I gave you the other link. It's up here. Right here is the link to that getting the C compiler installed. And then I gave you, yeah, so let me make a code snippet and give it C. This is all the work we did today. All right, so you've got all the code, no questions. We went through everything we needed to go to. I am incredibly sorry it took as long as it did, but it's a lot to cover in the first day, and I wanted to make sure we didn't blow through any of it. Everybody had a good understanding of it. So, like I said, follow your regular workflow, make Kai, add him as the contributor. Just know that you can DM me and that I'll be watching the channel, this Sprint 3 channel, in case there's any help questions. Posted in there until 3 o'clock Lambda time. After that, you can just DM Kai. He should be back. And tomorrow you will have memory allocation, which is another difficult aspect to see. I think the references that we did today is more difficult, but you'll see more of like what I did real briefly when I assigned that character, that pointer, that string, and I gave it 50 units of memory, and you'll talk more tomorrow about what's going on under the hood with that in C. Any final questions, or everybody good?
I'm good.
I'm good for now.
Okay. Well, that said, I'm going to go ahead and end this recording and turn everybody loose. So thank you for your patience, and hit me up if you need anything, okay? Good seeing you guys again.
Thank you.
Thank you.
No problem.